Hello everyone. Welcome to the first distribution that we are going to cover, which is the uniform distribution in our probability distribution series. So let's dive in. So there are two cases for the uniform distribution. One is the discrete case and one is the continuous case. Let's start with the discrete case. Suppose we have this nice dice and there are six faces of this dice. So if we now roll the dice, suppose landing on all the six faces are equally likely, then this is following a uniform distribution. That means probability of seeing an outcome of 2 is going to be 1 by 6. Probability of seeing an outcome of 1 is also going to be 1 by 6. Probability of seeing an outcome of 6 is also going to be 1 by 6. So they are equally likely, and so they are following a discrete uniform distribution. The probability mass function for this is very simple. It is simply 1 by n. So n being 6 right here. The expected value calculation is also very simple. So this is the formula that we derived in the previous lecture. So feel free to check that out. So if we do the math, what we are going to get, because pxi equal to 1 by n for all the xi's. So this is nothing but average. So if you take the average of these values, then you are going to get the expected value for this distribution. This is the formula for variance. So we derived this variance formula in the previous lecture as well. So for ex square, the xi will be replaced by xi square and everything will remain the same. So this will be the formula for the variance. Next, let's talk about the continuous case of the uniform distribution. So suppose we are trying to model how late a bus is. And let's assume that the bus is uniformly late between 2 to 7 minutes at the bus station. So it can be late for maybe one day, it can be late for 2.5 minutes. Another day, it can be late for 3.67 minutes, but it is uniform. So we can model it using the uniform distribution. So here, A equal to 2, that means this is the starting time, and B equal to 7, this is the ending time, that means the maximum late time. This whole late time is uniformly distributed. So you can see that the height is the same for all the different late values, right? So the height here is 1 by b minus a, because as I said before, that the integration result has to be 1. That means the area under the curve, the area under the probability distribution function curve has to be equal to 1. So if we multiply 1 by b minus a by b minus a, the area will be 1. Okay. So this is how simple it is. So this is the probability distribution function to be exact. So it is going to be 1 by b minus a. If x falls within a to b, it is 0 otherwise. That means outside of a and outside of b, it is 0 because the bus is late only between 2 to 7 minutes. It doesn't come as early as 1 minute. It doesn't come later than 7 minutes. That's it. So how exactly are we going to get the expected value and the variance? So we are going to follow the formula that we derived in the previous lecture. So for example, here, as you can see, we are taking the integration instead of summing. We are integrating from a to b because all the other places are 0. So fx is 1 by b minus a in this a to b range. And if we integrate this, it will be a plus b by 2. So this is a very nice looking formula because when we say that the late time is 2 to 7 minutes, we are saying that the expected value is nothing but 2 plus 7 divided by 2. That means 4.5 minutes and some time in between, basically the middle point. So the next thing is the variance. So this is the variance formula, as I said before. So you can do the math here. Ex square equal to x square fxx dx. We know this. And we have to integrate right here. If you do the integration, then this is going to be the result. So this is going to be the variance of this. Now, understand one thing. I want to repeat this, although I talked about this in the previous lecture. If someone asks you, what is the probability of the bus being late for exactly 2.5 minutes, then the answer will be 0 because there are infinite possible late times, right? So at 2.5 minutes, for example, right here, there is no area. There is no area for a single point. So that probability will be 0. So those questions don't really make sense. This height that we are seeing here, it is called density or likelihood. So when we say that what is the value maybe right here, which is 4.5, that value is actually the height of the curve, and that height is called density or likelihood. It is not an actual probability. So if you want to get the probability, you have to actually talk about a range of values of A and B. So you can say that what is the probability of the bus being late between 3 to 5 minutes? Or what is the probability of the bus being late for less than 5 minutes? So some range. So the probability only makes sense for some particular range. So that is all for the uniform distribution. See you in the next video. Make sure to like and subscribe the video if this video was helpful for you. And there is a link in the description. You can donate to our channel for supporting our content. Thank you.